Hello, guys. Welcome back to Maths Zone African Motives. In our case, we are going to consider a revision, and that was from our Limpopo province. So that was our question paper, which we are going to consider for our grade 11 mathematics, and that was a paper one written in June 2025, and that was 100 marks, and you're expected to cover everything in 2 hours. So, guys, I'm not going to waste your time. We have done other question papers before, which is meant for the June examinations, all right, or for the June test that you're going to sit on. So make sure that you go through those question papers as well. You are going to see that most of the questions, they are just a repetition. The annual teaching plan is still the same from what we had in 2025, in 2024. So meaning to say, same layout of questions as we had from our 2024, 2025, 2026. All right. So we haven't, we do not have like changes in terms of the structure of the questions. So make sure that you go through those ones as well for your revision purposes. So also make sure that you go through the instructions and the information that you're given, that you're supposed to answer the questions, answer all the questions. There are four of them, and you're supposed to answer all and make sure that the answers are given to two decimal places where whenever you're rounding off, unless stated otherwise on that particular question. All right, so that was it. And for you to download the question paper, just go through the comment section. You are going to see a comment where you're going to click the link and download the question paper, or check the description of the video. You also have a link that you can tap on it, then it will lead you to the drive. From that drive, you can download question papers that are there. All right. So that is what you have, guys. Like I said, I'm not going to waste your time. Question number one, you were given 1.1 back to your grade 10 mathematics, all right, to see if you still understand the concept of numbers. All right. 1.1, if x is an element, and these are the values that x is going to represent, 0, 2, 4, 6, determine the values of x for which this is what? 1.1.1, undefined. For values, or for a value of x that you're going to put here, whatever that you're going to get is what? Undefined. Remember, when it is undefined, when an expression is undefined, that's where our denominator is what? Is zero. You cannot simplify a constant over a zero, any number 2 over 0 like that. It is what? Undefined. So we are looking into that consideration when we substitute the value of what? Of x that we're given, that the denominator is going to be what? A 0. So guys, 0 is easily obtained when these two numbers are the same. This is our denominator. When this is 4 and also x is what? Is 4, you're going to obtain what? A 0. So definitely this one was on a condition where x is what? Where x is equal to 4. So in our case, x was supposed to be equal to 4. So that will be the square root of 8 minus 4 minus 4. That's what? That's the square root of 8 over 0. You cannot simplify 8 over 0. It's undefined. 1.1.2, when it is irrational, square root of 3, square root of 5, those sets, the ones that we cannot simplify, that's irrational. You cannot write it in the form of a over b, where a and b are what? Are integers. You cannot write in that form. That is what? Irrational. So for which values of what? Of x. You can even test your values, guys. When x is 0, it was going to be 8 over, when x is what? 0. Let's start with a 0 there. So this is going to be 4 minus what? 4 minus 0, which is simply a 2. All right, 8 over what? 4 minus a 0 like this. This is going to give us a 2. So it was going to be the square root of what? Of 2. Can you simplify this? No, that's irrational, square root of 2. So it occurs for the value of x when it is equal to what? To 0. You are going to obtain what? Irrational, square root of 2. All right, let us move on to 2 when x is what? When x is 2, let us put 2 here. Square root of what? 4. And square root of 4 is 2. This is a rational number. All right, so this is not going to work. Remember, 4 worked when it is undefined, so you cannot use that. Then the square root, when x is what? When x is a 6, when you put a 6, it is going to be a negative. This one, if you put here x as 6, this is going to be a negative 4, and you cannot actually simplify the square root of negative 4. It is we cannot refer these under irrational numbers. These are actually complex numbers, all right, which we cannot simplify. We cannot actually simplify this one. It is under complex numbers where we deal with square root of what? Square root of negative values. We do understand the square root of 4 is 2, but the negative there limits us in our simplification. So for the best answer, we were going to take this condition where we've got the square root of what? Of 2, which occurs when x is equal to what? When x is equal to 0. All right, so that was it on 1.1. 1.2 is simply to solve these equations, and also we've got an inequality on 1.24. All right, anyways, we do understand that these are basic equations that you simply need to work on. So that's 1.21. All right, x squared minus 4x is equal to 0. So there we're simply going to factor out x. All right, this is a quadratic equation where x is the highest common factor. So I can factor out the highest common factor, which is x. So factoring out x, this is going to be x minus, divide by this is going to be negative 4 equal to 0. Remember the zero product, one of these is supposed to be equal to what? It is supposed to be equal to a 0. So therefore, here we already have the value of x, which is 0. And from minus 4 to the other side, x was going to be what? X was going to be a positive 4. So these are the values of x. X will be 0, or x is equal to what? X is equal to 4. All right, easy question for 2 marks. For 2 marks, that is what we had. Simply factorize. All right, followed by 1.22. All right, this one, the moment you're given correct to 2 decimal places like this, it means you're going to apply the quadratic formula or the completing of the square method. All right, you are either going to apply quadratic formula or completing of the square method. But for these methods, the quadratic equation is to be written in the form of what? Ax squared plus bx plus c is equal to 0. So that is, I need to take this 5x to the other side so that we're going to have the exact format. One side is to be equal to what? To 0. 3x squared, 5x is going to be a negative on the left-hand side. So that's minus 4 equal to 0. Then let us apply our quadratic formula. Negative b plus or minus the square root of b squared minus 4ac over 2a. So where our a is the coefficient of what? Of x squared. So in our case, our a was going to be 3. Our b, the coefficient of x, which is what? A negative 5. And our c is the constant, which is negative 4. So using our formula, our x is equal to negative b, which is negative 5 plus or minus the square root of what? B squared minus 5 squared minus 4 times a times c, which is a negative what? Which is a negative 4. Our c is a negative 4, everything over 2 times a, which is 2 times 3. So that is it. This is what you're going to have. And from this simplification, the negative was going to be a positive, all right? The square root of, simplify these numbers under the square root, a negative 5 is being squared minus 4 times 3 times negative 4 like this. That was going to give us 73 under the square root. And 2 times 3, that is what? 6. All right, so this is it, guys. We can use our calculator to find the exact values of x. All right, starting with a positive, I'm going to have 5 plus the square root of what? 73 over 6. All right, like this. So let us put it a decimal. And we can even fix our calculator to what? 2 decimal places like this. So it's going to be 2,26. Or x is equal to, let us put a negative. Here we're going to have a negative. All right. Remember, our calculator is fixed to 2 decimal places. So whatever that I'm going to have here will be to 2 decimal place. Negative 0,59, negative 0,59 like that. So these were the values of x which we needed from that quadratic equation. All right, just like that, for 5 marks, you have your answers there for 5 marks. All right, another equation under the sets. All right, as we are to consider our sets, we are given this under the sets. All right, 1.2 to 2 square root of x minus 3 is equal to x minus 3. Remember, what you need is to isolate the set so that you can square both sides of the equation. You need to isolate the set. So from our equation, the set is already isolated. It is on its own, like you have it here. This is the set. We do not have any other term being added or subtracted to it. We have a 2, which is a product. It's a single term, guys. When you are given a x. This is it's a term, but a plus x is on its own, a is on its own. But in this case, we treat this one as a single term. So when we say isolate the set, in our case, it is already isolated because the 2 there is simply part of that same square root. It is part of what we need, the 2, because it's what? Part of the product. When it is a product like this, it is simply a single term. So what you can simply do is to square both sides as it is like this. You square both sides. Taking note, if you're given ab to the exponent of m, that's a to the exponent of m, b to the exponent of m. Every term is raised to the given exponent. So 2 is raised to the exponent of 2. And that was going to give us what? A 4. All right? 2 to the exponent of 2. The square root is also raised to the exponent of what? To the exponent of 2. So the square root and this 2 cancels. You remain with what? X minus 3. So this is an expression. Put it in a bracket. So this is from the square root being what? Squared. Okay, then the rest simplify. There are 2 brackets of x minus 2. Expand those brackets, you're going to get x squared minus 6x plus what? Plus 9. All right, so simply have your 2 brackets, x minus 3, x minus 3. All right, your grade 8 mathematics. You expand the brackets, then from there collect the like terms. You are going to end up with this expression. All right, let us expand this bracket by 4. And that was going to give us what? 4 times x, 4x times negative 3, that's negative 12, which is x squared minus 6x plus 9. Since we need this format, it's a quadratic equation, the highest power is what? Is 2. So we are back to the format of our quadratic equation. All right, so I need to just have a 0 here. So I'm going to take 4x to the other side, 12x to the other side. So 4x to the other side is going to be subtracted here. It's going to be a negative, minus 12 to the other side is going to be what? Is going to be a positive. So meaning to say 0 is equal to x squared minus 6x minus 4x minus 10x. 9 plus 12, that's going to be 21. All right. A is equal to B, therefore B is equal to what? Is equal to A. So that's x squared minus 10x plus 21 is the same as it is equal to 0. This is just one and the same. Nothing has changed. We are not going to introduce any negative from what we have. So this is a quadratic equation, just like what we had. Any equation in this format can be solved by factorization where it is possible, like what we saw on question 1.21, or by the quadratic formula as we saw on question 1.22. So in our case, we can factorize this, right? Looking into this can be factorized. So yes, you can just apply your factorization. The coefficient of x squared is 1. So I'm just gonna have x and x here. Then simply focus on the what? On the constant term, which is 21. What are the factors of this term? 21, which will add up to -10. There are so many factors of positive 21. Guys, there are so many factors of positive 21. But the one that will give us a -10 when we multiply is the -3 and the -7 and the -3. If I multiply, I'm going to get positive 21. If I add, I'm going to obtain -10. So that's from what? -7 and -3. -7, -3. So that is it, guys. We are back to the product of two brackets giving us what? A 0. It means one of these brackets has to be equal to 0, or this x minus 3 has to be equal to 0. So x is equal to what? A positive 7, all right? Or our x is going to be to the other side, that will be a positive 3. So these are the values of x that we are obtaining from solving the quadratic equation, not from solving this set that we have. For us to solve the set, we must test these values that we obtained from our quadratic equation, as the quadratic equation gives us two possible values. But what about the set that we're given there? Is it satisfied with these two values of x? So let us test our values. So here we're just going to test. Remember, the set, it is 2 square root of x minus 3 equal to x minus what? 3. So let us test our values of x when x is what? When x is a positive 7. Put a 7 here, a 7 here. So that was going to be 2 square root of what? 7 minus 3. All right, so let us bring back to the normal mode. Press 8, then press 2. So the answer is what? Is 4. 4 is equal to 7 minus 3. That's a 4. So this is correct. So 4 is equal to 4. So this satisfies our equation. All right. What about when x is what? 3? Put a 3 here. Put a 3 there. All right. So we're going to have 2 square root of what? All right. So it's going to be 2 square root of 3 minus 3. And that's what? That's a 0. And here we've got what? A 3. 3 minus 3, that's what? That's a 0. So this also satisfies our equation. So for both values of x that we have calculated here, they do satisfy our equation. So these are the values of x. All right. Both of them, they must be taken into consideration as our solutions, right? Just like that, easy like that. You simply play around with your questions. That was for 5 marks. Then 6 marks for this inequality. All right, why a lot of marks like that? But anyways, that is it for an inequality. 1.24. 1.2.4, that's x minus 4 into x plus 3 is greater than or equal to -6. So that is solve this. So guys, do not be tempted in this question to take the brackets and equate them to 0 or equate them to -6 in order for you to have the critical values. No, it is impossible. You only do this condition when you are given 0 there. If it was a 0, that's where you can simply find your critical values. This is equal to 0, that is equal to 0, but not a constant, which is any other value there, like a -6. We cannot do that. So what are we going to do? We are forced to expand our brackets and reformulate a quadratic inequality in a proper way from our quadratic expression ax squared plus bx plus c. It is going to be greater than or equal to 0. Is it going to be less than or equal to? But we need to formulate something of that nature, a quadratic. So we are forced to expand the brackets. All right, x and x, that's x squared. X and 3, that's going to be positive what? Positive 3x. You are done with x. Then we're moving on to negative 4. Negative 4 times x, that's negative 4x. Then negative 4 is going to multiply positive 3, which is negative 12. All right. Remember, one of the sides has to be equivalent to 0, greater than or equal to 0, less than or equal to 0. So we have to take the what? The constant negative 6 to the other side of the inequality. So it's going to be what? A positive 6. All right. It was a negative. Now it's what? A positive 6. So that's greater than or equal to 0. All right. So let us simplify. We've got like terms in our case. So considering the like terms, positive 3x minus 4x, these are like terms. So it was going to be x squared, 3 minus 4, negative 1. All right. We have got the constant terms, minus 12 and positive 6. So minus 12 plus 6, that is going to give us what? Negative 6, greater than or equal to 0. Thus, we are back to what we are used to. As long one side is represented with a 0 like that, that's where you can consider your factorization in this case, as long one side is equivalent to a 0. So we can factorize this so that you can find what our critical values after. So factorizing here, that was going to give us what? All right, the coefficient of x squared is 1. So this is x, considering factors of what? Negative 6, which will give us what? A negative 1. The coefficient of what? The coefficient of x, negative 1. So negative 6, there are so many factors, guys, so many factors. But of these factors, where are we going to obtain a negative 1 when we add? That is between what? Negative 3 and what? Negative 3 and 2 here. So that's minus 3, a positive 2. That is what you're going to have. From these, you can determine the critical values. The critical values are the values of x that we are going to find when we equate these to 0. When we equate x minus 3 to 0 or x plus 2 to 0. So x was going to be what? A positive 3 or a negative what? A negative 2. So those are the critical values. X is equal to 3 or x is equal to negative 2. Which are the ones that you're going to use to determine the exact solution of the given inequality? So in our case, we are going to test that inequality either from this quadratic here or from these two brackets that we have here using any method. All right. So let us say we are to use the graphical method. Like I said, guys, we've got number line, we've got graphical method, so many methods. So I'm just going to use the graphical method. Then for the sake of revision, I want you guys to use also the number line to verify if you're going to have your answers the same. For the values of x that you're going to put, you must obtain what? A number greater than 0, which is what? Positive values. But if you're using graphical method, what you're going to need is the coefficient of x squared from our quadratic expression, from this quadratic, from your f of x. It is 1 like this. So if our a is 1, it means our graph is what? It is concave up. All right, so it's going to be concave up. So thus we've got two solutions and our graph is concave up. So that is it for the values of x. 2 is going to, negative 2 is going to be this side, positive 3 that side. So this is negative 2, positive 3. Okay, from our number line concept, but you are presenting on a graph. All right, so that is it. Where is this from our graph? Where is it greater than 0? That is above the x-axis, greater than 0, above what? The x-axis. In the x-axis, that's where y is equal to 0, remember. So above the x-axis, your solution is going to be this side or this side of our graph. So remember from our introduction, guys, this is what I presented. So thus, therefore, x is going to be less than what? -2, but we must put an equal to, less than or equal to -2, or x is greater than or equal to what? Greater than or equal to 3. These values on the right side. So that was it. We have an equal to on our question. So our solution also must carry the equal to. So that was it. So use or verify the number line. You're going to obtain the same answers on your number line. You must consider, where are you going to get what? Where are you going to get a positive? That is the consideration. Where are you going to get what? A positive between these three regions. So you're going to see this was going to give you a positive. This was going to give you a negative. This was going to give you a positive. So these will be your solutions. But like I said, try that one for the sake of revision, all right, and see if you're going to obtain same answers, all right? Then moving on to 1.3. So 1.3, we are given solve for x and y, the given simultaneous, right? That is what you were given here, 1.3. You had 3y is equal to x plus 1. Just going to call this equation 1. Then equation 2, it was x minus y into 5y minus 3x, and that's equal to 0. All right? So this is our equation 2. So remember, when you've got two brackets like this, whenever you expand, like x times x, when expanding is going to give us minus 3x squared. That's a quadratic. The y and the y there is going to give us y squared. Meaning to say the second equation is our quadratic, and the first one is actually a linear. The highest power on these terms that you're given is 1. So that's a what? A linear. So I said it is easier using the substitution method to work from a linear equation. You make either x or y the subject of the formula, then substitute into the what? The quadratic. So that was the easier part. So in our case, we're going to work with what? Equation 1. Make x the subject or make y the subject. So from equation what? From equation 1. So if I was going to make y the subject like this, I was going to work with a fraction, guys. Y is equal to x plus 1 over 3. I was going to work with a fraction, which you must be prepared to work with if you want that. But to avoid working with a fraction, I was simply going to work with what? With x, because x here is the coefficient of x is what? Is 1. So I can simply take the 1 here to the other side of the equation. So it's going to be 3y minus 1 is equal to x. X is already what? The subject. And this is not a fraction. It is easier to work with. So as for me, I'm just going to work with what? This one, where x is the subject. So in place of x in equation 2, I'm going to put 3y minus what? 3y minus 1 in place of x in what? In equation 2. Wherever we see x, substitute with its equivalent expression, which is what? 3y minus 1. That is the substitution method, just like that. All right, so in this case, we're going to substitute that's equation what? 3 into 2 into equation what? Equation 2 in place of what? X. So here we've got x. So it was going to give us, our x is what? 3y minus 1. So in place of x, 3y minus 1. Minus what? Minus y, this one that is already in the bracket. So minus y like that, all right? So this is it. The second bracket, that's 5y as it is. 5y minus what? 3x. So that is 3. Our x is what? 3y minus 1. So in place of x, put what? 3y minus 1 like that. So that is what you're going to have at the end. And this is equal to what? This is equal to 0. So with these two brackets, remember, guys, you are simply back to the 0 product. The product of two brackets is supposed to give you what? A 0. Yes, you can simplify what is inside the brackets, collecting the like terms. 3 minus 1, that is 2. So you're going to have 2y minus 1. This bracket, you're going to expand and simplify. So that's 5y minus 3 times 3. That's negative 9y minus 3 times positive 3. times positive 1 minus 3 and negative 1. That's a positive 3. Sorry for that. So meaning to say, this is going to give us what? 5 minus 9 minus 4y plus 3. So that's what you're going to have here. Minus 4y plus 3 is equal to 0. Guys, this is still the zero product. Remember, the product of two brackets giving us a 0, it means one of these brackets has to be equal to what? It has to be equal to 0, just like that. So y is equal to what? Minus 1 to the other side, that's positive 1. Then you divide by what? You divide by 2. In this case, you're going to take 3 to the other side, is what's going to be minus 4y is equal to minus 3, then divide by what? Divide by negative 4. So at the end, y is equal to what? 3 over 4. Just like that. So this is what you're going to have from the values of y. Y is equal to 1 over 2 or 3 over 4. With these values, you can substitute back in what? In equation 3, where x is already the subject, to find the values of x. Remember, our equation 3, x is already the subject of the formula, where x is given as what? That was 3y minus 1, is that so? Yes, 3y minus 1. So when y is what? 1 over 2, x is equal to 3 times 1 over 2 minus 1. So that was going to give us the value of x. 3 times 1 over 2. All right, then subtract 1. That is 1 over 2. So x is 1 over 2 for that. Or when our y is 3 over 4, so x was going to be in place of y, you're going to substitute what? 3 over 4, then subtract 1. So that was it for the value of x this time. I'm just going to put what? I'm just going to put 3 over what? 3 over 4 like this. And that was 1 and 1 over 4, or 5 over what? 5 over 4. So this is it. These are the values of x from the value of y, which is 1 over 2. Our x is 1 over 2. 3 over 4. Our x is what? 5 over 4. Like that. So that is how we can play around. Like I said, there are so many ways. Just try any other approach that you do understand in terms of solving these equations, but you're going to see that it was going to be one and the same in terms of your final answers. So for 6 marks, yes, something that is good, understandable. All right, 1.4, if x is equal to 8 is one root of this given equation, determine one root of y for which, all right? So guys, here you just play around. Already you're given the value of x. So if you check, this is x and this is x. The rest, like these numbers here are the same. If you check, this is 48, this is also 48, this is 14, this is 14. So what represents x on this equation is what? 3y minus 4. 3y minus 4. It is the one representing what? Representing x. So in this type of equation, you just take that 3y minus 4. It is the same there as what? As x. That is what it represents. Because these are the same. This is 48, same there is 48. This is 14, this is also 14. So when you are given that one of the roots now, if x is, you are given, it's a solution. It's just like the substitute method. When you find the value of x, you substitute that x to find the value of y. That is what is happening here, because we know that x is what? 8. So let's put 8. 3y minus 4 is supposed to be equal to what? 8, just like that. Solve for y. So 3y is equal to what? Take the minus 4 to the other side. That was going to be simply plus 4. 8 plus 4, that's 12. So divide by 3, divide by 3. That's y is equal to what? Y is equal to 4. That's the one root that is representing y from this case, all right? So that was it on question number 1, having a total of what? 28 marks, the whole part of our question number 1. Then moving on to question number 2, you were given, in this case, 2.1, determine the value of this without using a calculator. right? So remember, guys, I said whenever you're given this condition, simply factor out the highest common factor of what? Of the given numbers or terms, these exponents that you're given there. Simply consider what? The highest common factor. Factor out the highest common factor, which is the one that has got what? The smallest power. It has to be common, but with what? The smallest power. So that is what? 2019 compared to this 2019 is what? Is the smaller one. So is the smallest power. So I'm going to factor out the one that has the smallest power, which is 2 to the exponent of what? 2 to the exponent of 2019, just like that. So if I factor it out from the numerator, I'm simply going to what? Factoring out simply means you're dividing this over this. 2025 over 2 to the exponent of what? 2019. Same basis, you subtract what? You subtract the powers. So at the end, it was just going to be simply 2025 minus what? Minus 2019 like this, which is 6. So that's 2 to the exponent of 6. So that is the case, the guys, that you're simply going to apply. All right. So the same with this one, when you divide by this, you're simply going to subtract powers. 2023 minus what? Minus 2019. So that's going to be to the exponent of 4 over what? The same, factor out 2 to the exponent of 2019 in this, you divide. So it's 2021 minus 2019. That's 2. So that's 2 to the exponent of what? Of 2. You simply do the same concept, same basis. So you're going to subtract what? You are going to subtract the powers from that consideration. So that's 2 to the exponent of 2. 2019 and 2019 are the same. So if I subtract the powers, it's going to be to the exponent of 0, which is what? Which is 1. So that is what we're going to have. From there, you can simplify because these two are the same. You can simply cancel that and simplify your brackets in an easier way. 2 raised to the exponent of 6. 2 is multiplying itself 6 times. All right. So that was going to give us 64. 2 to the exponent of 4, that was going to give us 16. Here you can even use a calculator, guys. No one is going to know that you have used a calculator to simplify 2 to the exponent of 6 if you do not know this, all right? 2 to the exponent of 2, that's 4, minus 1. Then subtract 64 minus 16, that's 48 over 4 minus 1, which is 3. So if I'm going to divide 48 divided by 3, that was going to give us what? A 16. So when you're asked not to use a calculator, they mean at this stage, do not just use a calculator here and give the answer, say the answer is. But other stages like simplifying 2 to the exponent of 6, guys, it does not mean multiply 2 times 2. They want you to see multiplying 2 times 2 times 6. No, 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 no. It does not mean that. Use a calculator where it is what? Where it is appropriate. Where it is what? Appropriate. Like this division, these exponents. If you do not know exact values by your head, then use the calculator. All right, so the answer was 16. All right, moving on, 2.2 for 4 marks. Simplify 2.21. This is the one with 4 marks and the other one 4 marks again. All right, so it was just a play around. If we check here, it was just a play around on 2.21. 3 to the exponent of x plus 4 minus 6 times 3 to the exponent of x plus 1 over what? 7 times 3 to the exponent of x plus 2. So here I can choose to factor out, but before that, the 3 is common somewhere. Let's separate the terms to the exponent of x plus 4. So that's 3 to the exponent of x times 3 to the exponent of 4. Then on this one, we're going to have 6 times 3 to the exponent of x times 3 to the exponent of 1, which is simply a 3. All right. There we're going to have 7 times 3 to the exponent of x times 3 to the exponent of what? Of 2. All right. Which makes us to factor out what is common. All right. Very sorry for that. What is common in the numerator, as these terms are separated with a negative, it means we have this one as a single term and this one as well as a single term. So you can factor out what is common from there. All right. In our case, for the sake of time, we can factor out even 3 because there's 3 there. But most of you guys, if I factor out that 3, you get confused. So let me just take the 3 to the exponent of x, this one that you are used to. All right? 3 to the exponent of x, I'm going to remain with 3 to the exponent of 4 minus here, I'm going to remain with 6 times what? 6 times 3. All right? Over what? This is, all right, the denominator is just a single term. There is no need of you like you are factoring out. There is no factorization. It's a single term. So this and this can cancel. Remember, you're under a product. So simplify now the numerator. 3 to the exponent of what? Of 4. 3 times 3, 4 times. Like I said, on these ones, you can even use a calculator. So that was 81. 6 times 3, that is 18. If you multiply 6 times 3, that is what? That is going to give us 18 on this part. All right. So, guys, just pardon this. Just sometimes it just delays. I don't know, it's network or what. Then this is 7 times 3 squared. 3 times 3, that's 9. All right. 81 minus 18 was going to give you a 63. And 7 times 9 is 63 again. So 63 over 63, that's what? That's a 1. All right. So many ways of actually simplifying this. All right. But for this, you can get all the marks just like that, 4 marks. All right. So it's a matter of playing around, guys. Go through the introductions, all right, where you can figure out so many ways of answering these questions, all right, from the introductions that we have. All right. Let us move on to question 3, 2.2. Sorry, because we still have, I thought like that's 2.22, this one. All right. There we have got a square root and another one, the square root of x plus the square root of what? 4x minus 4. Okay. All right. This is a separate one. Then the other one, it's the square root on its own times the square root of x minus the square root of 4x minus 4. All right. So here they're simply trying to play around with us. Let's consider the square root and square root, this outer square root and this outer square root. When you're multiplying two square roots, all right, the square root of a times the square root of b, this gives us square root of ab from our cells. All right, square root of what? AB. So you simply multiply the terms under the square root with that square root covering those terms. So it was going to be the square root of the product of these two. What is inside the square root here? X plus this. And what is inside the square root of this one? So you multiply those two together. So it was going to be x plus the square root of 4x minus 4 times x minus the square root of 4x minus 4 like this, which is giving us another aspect in our mathematics that is very, very important. What is inside the square? These terms that we are multiplying, this bracket and this bracket, are we saying that is a special case of our factorization of the difference of two squares? There is a plus, here there is a minus. The same, they are the same. This is x, this is x. Square root of 4x, square root of 4x minus 4. Same thing. So we're back a minus b into what? A plus b was taken from what? A squared minus b squared. Difference of two squares. So it means this was going to give us the square root of, this is our a, this is our b, this is our a, this is our b. So it was going to be square root of a squared, which is what? X squared minus b squared. Our b represents what? The square root of 4x minus 4. But you must what? Square that. A squared minus b squared. You square those under the difference of two squares concept. So what are you going to have at the end? The square root, okay, of x squared minus, here we've got a square root and a square. This neutralizes. So you're going to remain with what? 4x minus 4 under the bracket, since we've got a negative that need to expand that. So this is what we have at the end. All right. this is what you're gonna have at the end. So from here, you can expand brackets, then try to factorize, all right, negative 4x, negative, that's a positive 4. So factorizing x squared minus 4x plus 4, it was going to be xx. Factors of 4, which adds up to negative 4. Factors of 4, there is negative 2 and negative 2. If you multiply this, you are going to get a positive 4. Add this, you're going to get a negative 4x. So that's negative 2, negative 2. X minus 2 means what? X minus 2 squared, just like 2 times 2, 2 squared. So meaning to say, whatever that you're going to obtain under this square root here, it is what? A bracket being squared, which is easier for us to determine its square root. So that was x minus 2 squared from the factorization that gave us these two brackets, right? So that's x minus 2 squared. Remember the concept. Why is it that we need a square? Because a square root and a square neutralizes. A square root and a square simply cancels out. So meaning to say, you are going to obtain what? X minus 2 as your final answer. That is the corresponding answer, the square root, and the square simply what? Simply cancels, just like that. So you see, guys, maths, so many ways actually that you can answer this question. So I want you to figure out other ways. Let us communicate. The comment section is there. The community section is also there, where you can even send your working, all right? Take a picture of your working, then you upload it on the same channel on your side, and you can ask a question about that. So that is the easier way. Instead of you guys trying to look for the WhatsApp number, WhatsApp group, this and that, use the same platform, Maths on African Motives. Go to the community section on your phone or on your laptop, send the question that you do not understand, or send the calculation to that question to verify if your calculations are correct or not. Or maybe you're doing a home activity. Is it a homework? You can send that question, then we can assist each other in form of a video explanation. All right, that's the easier way where we can connect each and every time. All right, 2.31, solve for x. 2.31 was, all right, let me quickly have this one. 5 to the exponent of the square root of x is 125. Remember, if the bases are the same from our exponents, we can simply equate our powers. So thus 125 can be written in the base of 5. All right, 125 is equal to, then you're going to press shift and fact, 5 to the exponent of 3. So 5 to the exponent of the square root of x is the same as 5 to the exponent of 3. Where the bases are the same, we equate the powers of the exponent. The square root of x equate to 3. So find x. I'm simply going to square this and square this. So this neutralize. So x is what? 3 squared. 3 times 3, that is what? A 9. Like that, right? So it was an easier question, just like that. Just like that. You've got what? 3 marks. 2.32. That's back to our factorization if we want, or simply, all right, so many ways. But that one, it was actually having an error. This question here was actually having an error. So let me just show you guys quickly. If you go through here at the end, 2.32, it was actually having an error at the end. If we were going to try to solve it, you were going to see that at the end, you're not going to be able to solve that part here. You're not going to be able to solve. There are no solutions at all. Even if you try to use the K method, you form an equation in K, you're not going to have solutions at the end. So it was actually not having real solutions. In this case, it was just an error. In terms of this number 2 here, it was supposed to be 8 instead of what? Instead of a 2. So, but in case of revision, that is what you're going to have. So here, guys, this is our question 2, which is presented here. It was just an error of the question. So anyways, for the sake of revision, just try and work out that part, just add more, but that is it for this one, guys. You saw it. It was just not going to give us exact solutions at the end, unless that 2 is going to be 8. Yes, you can solve, but as for this one, you were going to be stuck around because of what? Not having solutions. All right, question number 3. Given this function and this one, we have got a hyperbola and an exponential here. So those are the two functions that we're given. So 3.1, it was write down the equations of the asymptotes of f, a hyperbola. So remember, from a hyperbola, asymptotes are taken from x minus 2. You equate that to 0. So x is what? X is 2. So x is equal to 2. Then the y is what? 4. Y is equal to 4, like that. Okay. Then calculate x and y intercept of f. All right. So the x-intercept and the y-intercept can be calculated. All right. Remember, for f, we're talking about f. So if it was the x-intercept, all right, if it was the x-intercept, y is equal to 0. So that's going to simply put a 0 here, equate to what? 4 over x minus 2. All right, plus 4 like this. So let us solve for x. Take this to the other side. That was going to be a negative 4 equal to 4 over x minus 2. So to find x, I can simply take this as over 1, then cross multiply. So that's negative 4 into what? X minus 2. It is supposed to be equal to 1 times 4, which is 4. So let's expand our brackets. Negative 4x, positive 8, that's equal to 4. Negative 4x is equal to what? 8 to the other side, that's a negative. So 4 minus 8, that's minus 4. Dividing by negative 4, our x was going to be what? A positive 1. Meaning to say, considering the x-intercept, in this case, that's at 1, and y is equal to 0. Remember, for the x-intercept, y has to be equal to 0. Then the y-intercept, just like the x-intercept, it has a condition, all right? When it is with the y-intercept, x is what? X is equal to 0. So put a 0 there. So y is equal to 4 over what? 0 minus 2, that's minus 2 plus 4, of which you can just use your calculator here. That's 4 over what? Negative 2, or 0 minus 2. All right, then plus what? Plus 4. And that was going to give us a 2. So y is equal to 2. That's therefore the y-intercept when x is what? When x is equal to 0, y is 2. So you're going to take that value. That's our y-inter. When x is 0, y is what? Y is 2. Okay, just like that. Just like that. Then here we need the domain of what? Write down the domain of f. Remember, when dealing with a hyperbola, the domain is on the x asymptote, on the equations of the asymptotes from the x value. X cannot be equal to 3, as it is what? Cannot be equal to 2, I mean, as it is an asymptote. The graph can be taken in within these values, but not at x is equal to what? Not at x is equal to 2. So x cannot be equal to 2, even though this x is what? A real number, any real number, but not to be equal to what? Not to be equal to 2. All right. Remember the properties, guys, of each graph as you have these in your syllabus. Then 3.4, determine the equation of the axis of symmetry of f, which has a negative what? Gradient. So remember, from a hyperbola, the equation that has got a negative gradient is written in the form y is equal to minus x plus c, minus x plus whatever constant according to your textbook. You can use a, b, p, any constant, all right? But here it's minus x. If it was positive gradient, y is equal to x plus c. So already we know this is negative 1, this is positive 1. What we simply need is to find the value of the constant what? The constant c. From where? From the asymptotes. The gradient, I mean that axis of symmetry passes through the intersection of what? The asymptotes. like that, all right? So it passes through the intersection of the asymptotes, where in our case, x is what? X is 2 and y is 4. So that's a point that can be used, all right, to determine the value of c as the line passes through the asymptote. So that is it. Y is what? 4. And the asymptote, where x is what? 2. So find your x negative. To the other side was going to be a positive. That's positive 6, 2 plus 4. So that's our c. So therefore, y is equal to minus x plus what? Plus 6. Remember, the value of c is what? Is a positive 6. So there we have got the axis of symmetry that has got a negative what? That has got a negative gradient, right? So just like that, that was our 3.4. Then moving on to 3.5, calculate the x and y intercept of g. Now we are on the graph of g, the exponential what? The exponential graph that you're given there, where the g of x is 2 to the exponent of x minus 2. So the x and y intercept, all right? Let's start with the x-intercept, where y is equal to 0. So that's 0 is equal to 2 to the exponent of x minus 2, minus 2 to the other side. That's 2, 2 to the exponent of x. Same basis, equate the powers. So this is what? 1. So equating the powers, it means x is equal to 1. When y is equal to 0, so here our x-intercept, when x is 1, y is what? 0. Just like that. Then for the y-intercept, just like the case for the y-inter, x is equal to what? X is equal to 0. So y is equal to 2 to the exponent of 0 minus 2. 2 to the exponent of 0, that's 1. Any number to the power of 0, guys, is 1. So y is negative 1. So that's our y-intercept, where x is 0, y is what? 1 minus 2. This is negative what? Negative 1. So y is negative 1. Just like that, you are done on this graph of gx. Write down the equation of the asymptote on 3.6. So our asymptote here, the number that is being subtracted from 2 to the exponent of x, which is what? Negative 2. So that's our asymptote. Y is equal to negative 2. Then 3.7, it was to sketch the graphs of f and g on the same axis, on the same system of axes. All right, we need to sketch these two. Okay, so let us see what we can do. Right, this is just a sketch, so I'm just gonna try. All right, remember our f of x is a hyperbola, and what is important on a hyperbola, guys, you must know the important aspects of each and every graph. All right, just for the sake of space, I'm going to have it here. This is 3.7. All right, so I'm just going to have it here, guys, just for the sake of space. I'm just going to have a little sketch here. All right, it's just going to be a sketch, the y-axis and the x-axis like this, 0. Let's just say 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4, negative 1, negative 2, negative 3, 1, 2, 3, 4, and so on. We have values of y up to 4. Now, y is equal to 4 is an asymptote. So when you say the graph here is going to go up, all right, I was supposed to just take this one. All right, no problem. Let me just do this. All right, so that's 4, 5, 6, 7. All right, so let's start with the graph of f. Let's focus on f, where our f of x is a what? Is a hyperbola. Let's start with f. So first of all, on f, what we need is the shape from the asymptotes on a hyperbola a, which is our 4 here, represents the shape. So if it is a positive like this, it means we're going to have one piece on this side and another piece on this side of the what? Of the asymptotes. So our asymptotes, remember they were at x is what? X is 2. So we're going to start with the shape first. X is 2. That is here. So we're going to have an asymptote there. So our graph is limited. It cannot pass the line of x is equal to 2 and the line of what? the line of y is equal to 4. This is where we've got y is equal to 4. All right. So we're going to know that the shape is going to be somewhere here, a piece there, and another piece here. From these asymptotes, we've got another that's this side and another one this side. So as you can see, the graph that you're going to have here on this in this quadrant of our asymptotes must have the y-intercept and the x-intercept. That's where those intercepts play a role. So we're going to need those intercepts. Calculate the x-intercept of f. Remember, x-intercept was what? 1, 0. The x-intercept, 1, 0. The y-intercept, 0, 2. So that with these asymptotes, with these intercepts, we can have our sketch passing through 2 and what? 2 and 1 like this. It tends to reach the asymptote, but it won't reach that. All right, so that was the case of our graph. This is 1 and this is 2. So that's the graph of H. On this side, it is just going to be another piece which is similar to this one. Since here we do not have any intersection with the axis, this part here cannot intersect with the x-axis or y-axis, as it is limited by what? These asymptotes. All right, so that's the graph of F. This is our F. All right, then the graph of G, being an exponential function, what is important is the -2 here, our asymptote. It cannot pass that -2. So -2 is a what? Is an asymptote in the y. Y is equal to -2. And the x-intercept and y-intercept of that graph, remember our x-intercept 1, the y-intercept at -1. So x-intercept 1, the y-intercept at what? -1. Remembering the shape, from this b, our b is greater than, so it's actually positive. So it's going to be an increasing function. So here we are going to have an increasing function passing through -1, passing through +1, like this, and increasing, going wherever that is going to be, whether it's going to meet with this one later on. We do not know what's going to happen, but that was it. So this is the graph of what? Of gx, which is an exponential function, which had the x-intercept at 1, the y-intercept at -1, limited with this asymptote where y is what? -2. So there I have indicated the two graphs on a single axis, all right, on the same axis, all right. So that was the idea of our question. We must have it on the same. All right, then 3.8, we are asked here to determine the values of x for which f of x is greater than or equal to gx. F of x must be above what? Above gx. But where x is what? For values of x which are less than 2. Values of x which are less than 2. This is where we've got our x equal to 2 on the what? On the asymptote. But we need for the values of x less than 2, meaning to say on this side, not this side is not required. This one is not required. Less than 2, that's facing this side. So you're limited only this side. That is where you are limited here. This is the side which you are limited. Can you find a condition where f of x is what? Greater than or equal to gx. Which condition is that? All right, so that was our 3.8. Where is it that f of x is greater than or equal to gx? But for what? For values of x that are less than 2. You're going to notice that where f is above, that's greater than, it must be on top of gx. So our f, where it is found on top of gx, it is here. You can see this is our f. It is above gx. Our f here, our f up to what? Up to 1. From 1, our f is now below gx. So this is happening from this 1 going to the what? To the negative side for values of x that are less than what? That are less than 1. So it is for x which is less than or equal to 1. So you must put that as your solution, all right? Where the graph of f is on top is above this one of what? Of g. So here, the y values of what? Of h are more than the y values of what? Of g in that region. F is on top of what? Of gx. Just like that. All right. Then the graph of f undergoes the transformation, which is represented from to form this hx, which is this one. So from here 3.91, determine the horizontal asymptote of what? H. The horizontal asymptote of H, guys, the horizontal asymptote of what? Of H. You can simply find horizontal asymptote. That's when you are given like this, horizontal. All right, so guys, what am I doing? This is vertical, horizontal, something like this. This is what? A horizontal asymptote. So we are talking about an equation in the form y is equal to. So we cannot see it here from this presentation. So in order for us to see that, let us divide x plus 2 over x minus 2. You divide, say x minus 2 into this is going to be how many times? So it is going to be 1 time, since we've got the same power here of x and x. So it's going to enter there once. Then you subtract to get the remainder. You're going to subtract, all right, x plus 2. You subtract x minus 2 to get what? The remainder. X plus 2 minus this one. So it was going to be x plus 2 minus x minus minus plus 2. X minus x cancels, 2 plus 2, that's a 4. So 4 is our remainder. So you add 4 over what? The denominator of x minus 2. That's a division. So it goes there. It enters here once. Then the remainder is what? Is 4, which we can write as 4 over what? X minus 2 plus what? Plus 1. In this format, we can properly see our horizontal asymptote of h. All right. Remember, this is our hx. So we can properly see the horizontal asymptote. Y is equal to, that's the equation of a horizontal asymptote. So y is equal to what? Y is equal to 1 here. So therefore, our horizontal asymptote is what? Y is equal to 1. All right. Then determine the type of transformation from F to H. All right. From F to what? From F to H. Our F, remember, it is there. We are given this. This is our F. So take that F and see what happened from F. Our F of x is given as 4 over x minus 2, all right, plus a 4. But this is our hx. Our hx is given as 4 over x minus 2 plus what? Plus 1. So if we check properly, guys, we're going to see that 4, this is a 4, this is the same. X minus 2, x minus 2. So the only transformation occurred between these two, 4 and what? 4 and 1. So from our f of x, what happened was we want a transformation that happened from f of x to this hx. What happened in order for us to get what? A 1. We simply subtracted a 3. 4 minus 3, that is what? A 1. So meaning to say our hx from f of x, we subtracted what? 3. So f of x minus f of x plus f of x plus or minus a. That's a translation. Plus a units up, minus a units down. So this is what? Simply a translation from our transformation. Check the transformation notes even for grade 12 mathematics on the playlist. There is a transformation you can understand much better in advanced explanation of what your transformation. But from our grade 8, guys, we talked about this f of x plus a, f of x minus a. So if it is a negative, it means you're going down. That's a translation. So that's a vertical translation that occurred. Here, a vertical translation of what? 3 units down, 3 units down as you are going vertically. It was 3 units going down, a negative. If it was a positive here, 3 units up. So do not confuse to f of x plus or minus a inside the bracket. These ones are horizontally taken. But if it is f of x on its own, then plus or minus something from your f of x, not f of x plus like this is a different thing. These ones are horizontally, this one vertical. So there are two types that is totally different in terms of what the presentation. So do not confuse your answers in terms of what the presentation. But as you can see, that was it. That was it for question number 3, a total of what? 25 marks. So it was actually, yeah, an understandable question. Just a lot of things that you have to remember. You have to remember a lot of things here and also the sketching part. So guys, I advise you, take seriously of your grade 11 mathematics. You see that in grade 12, guys, it is just a walkthrough. This is grade 12, this one, as you can see, as it is. So if you take this for granted, you'll see that grade 12, guys, you are going to repeat what you have done in grade 11 to understand it from the beginning. Something that you could have taken into consideration before. So I advise you guys that we take this seriously from now. All right. Number 4, the diagram below shows f of x and gx. These are graphs that are being drawn here. So we have got this, our f of x, all right, and this is our gx, all right. They are not given their equations. We're just given these points, the point F, 1, 6, which is a point of intersection, and D, and T and U are the x-intercepts of F, all right. Then E is the point 0, 6, all right, like that. Then V, W, this one is a line parallel to the y-axis. Okay, so that was it, guys. That was it. That was it. That was it. Okay. So I'm just gonna need these two for the sake of calculations. For the sake of calculations, that's mx plus q. All right. Let's see. Let's see what we have here. So this was it for 27 marks, and plus, we are done. Okay, if you can get this 27 marks, you will totalize everything. So you see, maths guys, you can totalize. I want you guys to obtain 100 out of 100, 100 out of 100 every time you write your mathematics, and you must send me those results, guys. I want to properly see. All right, 4.1. Write down the equation of the axis of symmetry of F. The axis of symmetry of what? Of F. So F here is a quadratic function where the axis of symmetry is actually in between at the turning point. That's where it divides the graph into two equal parts. So what we're going to use? We're going to use advantage here, the point F, which is 1, 6. The point E is what? 0, 6. So if you check properly, point E and point F, they form a horizontal line, these two. They have got the same value of Y. Same value of Y, which is 6. So if we were to join E and F like this, we're simply going to form what? A horizontal line. All right, same value of 6, guys. The Y value there is 6. This Y value is also 6. So the axis of symmetry is the average from any horizontal line that is being drawn from that graph. It can be the average of this point T and U. You take the X value at T plus the X value at what? At U. Let's say we know that one, divide by 2. It gives us what? The axis of symmetry, because it is from a horizontal line. So you were used to that because it is in the x-axis. We are not talking about much, but the idea there was it must be from a horizontal line. So then they avoided now to give you that condition. They are giving you this, the point E. The x value at E is what? The x value at E is 0. At F, what is the value at F? It is what? It is 1. So what we need here as the axis of symmetry is in between these 2 points, 0 and 1 of that horizontal line. So that was the idea, guys, of our question. So yeah, that's why they're saying write it down. It's not even calculate. You can just look into it. What is the distance in between 0 and 1? That is what? A half. The average. All right. So that's our 4.1. So the axis of symmetry, x is equal to what? because it must be given in the form of x is equal to. So x is equal to, like I said, we are talking about this one in between, in between what? In between 0 and 1. So that's the x value at E, which is 0, plus the x value at F, which is 1 over 2. So that was going to be 1 over 2. So that's our axis of symmetry. At this point, I mean, on this line, x is equal to 1 over 2. Throughout that line, x is what? 1 over 2. So that's our axis of symmetry from the average of what? X values in any horizontal line from that graph, all right? 4.2, for which values of x is f increasing? When the graph is increasing from our condition here, this is what? Concave down. So the graph is increasing from these values like this up to the turning point where x is what? A half. It is increasing up to the turning point. From the turning point, the graph is what? Decreasing. The y values now, they start to decrease, going down. So to note if the graph is increasing or decreasing, you work it from what? The turning point. So from this turning point, we're talking about values of x compared to what? 1 over 2, where the graph is what? Decreasing. These values of x, they must be what? Less than 1 over 2. So you're talking about values of x which are less than 1 over 2. At the turning point, the graph is stationary. There is no movement. From x is equal to 1 over 2 going this side, the graph is what? Decreasing. It is now going down for values of x that are greater than 1 over 2. So 1 over 2 at the turning point is just like a critical value. It is actually a critical value that you use to test or to see where the graph is increasing or whether it is what? Decreasing. So for these values of x, half, 0, this going this side, the graph is what? Increasing. The graph is going up for those values of x. So that is the whole idea for an increase. All right. Then 4.3, calculate the average gradient of f between D and E. The average gradient between D and what? E. So the average gradient is just a gradient that we're going to take using the 2 points D and what? D and E. Using the 2 points. That's the idea of the average gradient. So at point D, we have got -1 versus 4. And E is what? 0.6. So you simply calculate the gradient from the formula of our gradient given what? 2 points. y2 minus y1 over x2 minus x1. So it is up to you which one are you going to represent as your y1. And so here I'm just going to call this x1, y1, x2, y2. So y2, that is going to be according to my presentation. Y2 is going to be what? Y2 is going to be the y value at E, which is 6, minus y1, the y value at what? At D, which is 4, over x2, the x value at E, that's a 0, minus the x value at D, which is -1. So that is our condition. So that was going to give us the average gradient. You use the gradient formula that you are used to for average gradient. So 6 minus 4, that's 2. 0 minus -1, that's 1. So that gradient was equal to what? Was equal to 2. You can write it as from D to E, M, D, E like that if you want, or just write M for what? For average gradient. Okay, then from there, determine what? Determine the equation of G. The equation of what? Of G. Where is G? The G is the straight line here. So we can determine its equation. All right, let's see what we have. Actually, we do not have anything, just 2 points on what? On G. Just 2 points. So that's 4.4. So gx, that's a straight line. Mx plus what? Q. So in order for us to have the equation, we're going to need the gradient and the y-intercept. So we need to find M and what? M and Q. So I'm going to utilize or take advantage of point D and F. Since point D and the point F here, F and D lie on what? On G. So use what? D and what? And F. So that is the idea there, all right? So I'm just going to use D and F. So that's x2, y2. Use D and what? F to find the gradient. So M from our formula, like I said, M is simply what? The change in y over the change in x. So that's y2 minus y1 over x2 minus x1. That's the gradient. Y2, the y value at f, which is 6, minus the y value at d, which is 4. The x value at f, that is 1, minus the x value at d, which is what? Negative 1. So that was going to give us the gradient of what? Of the straight line. So that is it, guys. Our m is what? 6 minus 4, that's what? 2. So it was going to be 2. Then 1 minus minus 1. Remember, this is a negative, so it's going to be positive 2. And m is 1. All right, so that's our gradient. I'm trying to figure out if there was any other way. We do not have this y-intercept. So unfortunately, we do not have the y-intercept so far. So meaning to say you have to calculate that from where? From any point which lies on what? Which lies on gx. You can use the point D, you can use the point F, any point. So in this case, I am going to use what? Negative 1, 4. So using, actually, yeah, using the point negative 1, 4, find the value of what? Q. Find Q. So you substitute that, all right? Remember, y is equal to mx. So here, no problem. I'm just going to write gx, the one that you are given there. So m is 1. So that's 1x, which is what? X plus q. So to find q, we need the point that lies on the what? On the graph of G. Anyone, D or what? D or F of those two. All right, so the y value at point D, using the point D, the y value is what? 4, when x is what? Negative 1. So plus q. Find the value of q. All right, taking negative 1 to the other side, it was going to be 1. 4 plus 1, which is 5. So that's it. 5 is equal to q. So therefore, our equation for that straight line was going to be gx is equal to mx, which gave us x plus q. Our q is what? Is 5. So our gx was going to be x plus 5. And as you can see, the 5 there represents what? The y-intercept, where the straight line passes or crosses what? Crosses the y-axis, as we have got our graph here, where the graph crosses the y-axis. That is the condition that we are given, but it was just to find the what? The equation. All right, just in case where we're going to need this equation of that linear, please do remember our equation, all right? In case we're going to need this with gradient, then you find the value of q from there. All right, just like that, that was our 4.4 of this question. Let us consider the other part, which is 4.5. All right, 4.5 show that f of x can be written as this, all right, for 5 marks, f of x. All right, let's figure out our f of x is the quadratic function. So what can we do? What is that we have from that quadratic function? There is nothing, guys, at all. It is no intercepts. We do not have the x-intercepts. It is just points along the graph. It is just points along the graph. All right, let's take our f of x into consideration. F of x is equal to negative. All right, so they wanted to prove, but here it's given as what? Ax squared plus bx plus c. C is the y-intercept, and we have that on f, or f, or f, or f, or f passes through the y-axis at what? At E. The y-axis is at point E. So we have got the y value, which is what? 6. That's our C. When x is equal to 0, so it means f of x is equal to ax squared plus bx plus 6. So we can take advantage of that. So that if we know that this is already a 6, guys, we can use the 2 points. Since we do not have the x-intercept at t and at u, we do not have that. So this time we can use now advantage of the 2 points which lies on what? On f of x, any 2 points, because what we need is to find a and b. Those are the two unknown values only to be calculated. So use any point which lies on what? F of x. D lies on f of x. F lies on f of x. So we can use those 2 points to find the value of a and b. But definitely you are going to formulate simultaneous equations at the end. All right? Because we are saying when x is -1, y is 4. So from what? From point D, when x is -1, y is what? 4. So 4 is equal to x is what? -1. Put -1 in place of x. Put -1 in place of x. Remember here we already have what? A 6. For this constant, we already have that one. So this is from point D. Let's simplify. -1 squared, that's 1 times a, that's a, -1 times b, minus b plus 6. So let's take the 6 to the other side. It was going to be a negative on the other side, -6. So it means a minus b is equal to what? 4 minus 6, that's a -2. All right, so a minus b is giving us a -2. From what? From point D, we have formed an equation. What about from point F? Because these are the 2 points which lies on what? On f of x. Yes, they also lie on gx, but they are also found on what? F of x. So we can also apply the point what? The point F. So from what? From the point F, where x is what? Where x is 0, where x is 1 and y is 6. It follows that f of x, that's our y, 6 is equal to what? 6 is equal to a x squared. Our x is what? 1. So that's 1 squared plus bx, b times 1 plus 6. All right, remember we already have 6 there. So 6 to the other side, that was going to be -6. Then you obtain a 0 there. 1 squared, that's 1 times a, that's a. 1 times b, that's b. So a plus b is equal to what? 0. That's the second equation. Using these two equations, guys, we can solve for a and b. So that is it. Either you're going to use substitution method, elimination method, guys, any method that you want, you can use it to determine the value of a plus a and what? A and b. So in our case here, guys, anyone. So I can even just eliminate, all right? Using elimination, I can eliminate what? I can eliminate a by subtracting equation 2 from equation 1. That's equation what? Equation 1 minus equation what? Equation 2. A minus A, that's a 0. Minus B, that's minus 2B, equal to -2 minus a 0, that's -2. So to find the value of B, divide by what? A -2 both sides. So our B was going to give us a value of what? +1. Just like that. So using elimination method, as we have determined the value of B, substitute in any one of the equations to determine the value of A. So using equation 1, using this equation 1, anyone that you want, you can use equation 2, all right? Some can just easily equation 2, A plus B is 0, but even equation 1, A can be calculated. So A minus what? B, or B is what? Is 1. It is supposed to give us a -2. So what is the value of A? All right, simply add 1 both sides of your equation to get rid of this. So A is equal to -2 plus 1. That's a negative what? A -1. So that is it, guys. We can show that our f of x can be written as what we are given, as we have got the value of A, B, and C. So therefore, our f of x was going to be written as what? A is what? -1. A is -1. So that's -x squared. Our B is what? A +1. So that's plus what? Plus 1x, which is plus x. Our C, remember, it was the constant that we saw from the y-intercept, and we said is what? It's 6 already. We already have that. The y-intercept of what? Of our f of x, which is occurring at point E. We already have that one. So that was the idea, guys, just like that. Formulating equations from the points which lies on what? F of x. Because we do not have the x-intercept, so you're not going to use the method that f of x has to be equal to a into x minus x1, this and that, x minus x1 into x minus x2. We do not have the x-intercept. So that is limited. We do not have the turning point, so we are limited to use the method x plus p squared plus q, where we've got a turning point. We just have the value of x at the turning point, but we do not have the value of y at the turning point unless you were going to find that value by substituting the points, then you expand. All right, someone can do that. Someone can do like that. But in our case, with so many limitations, so this was going to be easier. I'm not saying it's the only way, but it was just going to be easier. Just solve your simultaneous equations, guys. You're done. And as you can see, they were just easy equations to solve. You do not have a lot of work in order for you to solve these two simultaneous, two equations that we had there. The simultaneous, guys, it was just a direct one. All right, anyways, determine the range of f, all right? So the range of f, we are talking about the y values. And these y values for f, they are limited at the turning point, all right? Remember, we're talking about the graph of f. So the range is limited at the turning point going down. So meaning to say, from that f of x, you are going to need what? You are going to need the value of y at the turning point. All right, remember, this is our f of x, where we said our f of x is, all right, I have already erased it, but it was minus x squared plus x plus 6. Remember, that is our f of x. So for you to determine the range, guys, you simply need what? The value of y at the turning point, as the graph is limited at the turning point, like that. Dealing with the quadratic function, if it is like this, from the turning point going up, the y values are greater than the value of y at the turning point, greater than or equal to. If you're dealing with this type of a graph, which is concave down, from the turning point going down, so the y values are limited, less than or equal to what? The y value at the turning point. So that is the condition that we are working with here. We need that y value at the turning point, where x is what? 1 over 2. What is the value of y there? You simply substitute. So that's the part of the range. So at the turning point, remember, x is equal to what? We already have this one. X is equal to 1 over 2. Guys, we talked about this value. I think it was on first one, axis of symmetry of f. That is the x at the turning point, that value that we determined before. So using that value, substitute it into f of x to determine what? To determine the value of y at the turning point, if x is what? 1 over 2. So therefore, y is equal to what at the turning point? Substituting into our f of x. So that's minus our x is 1 over 2. So that's 1 over 2 squared plus our x 1 over 2 plus 6. So that was going to give us the value of y corresponding at the turning point, and your range can be calculated from there. All right, so that's negative, open bracket, 1 over 2, you square this one, all right, plus 1 over 2, all right, plus what? Plus 6. That was going to give us 6 and 1 over 4, or 25 over 4. So we are saying at that turning point here, where x is 1 over 2, all right? At this turning point where x is 1 over 2, the corresponding value is 25 over 4. So y is limited from that value going down. The y values are limited from that. That's the range. So y will be what? It will be less than that. So meaning to say, for our range, in this case, y is going to be less than or equal to what? 25 over 4. Values limited from the turning point going down. They are less than that or equal to 25 over 4. That was the idea there, just like that. So you see, guys, it's just a matter of playing around with the questions here. Then calculate the length of SU, the length of SU for 5 marks from S to U. All right, where do we have the point S and the point U? All right, if you check S and U, they are on a horizontal line, actually in the x-axis. All right, S and U, guys, S and what? And U. So this distance between S and U is the one that we need. So that is the condition. So if we check properly, it is a horizontal distance that you are referring to. So simply subtract the x value at U, this one, all right, the x value at what? Since it's a horizontal line, the x value at U minus what? The x value at what? The x value at S. So that was the consideration. So what is the x value at what? At U. What is the x value at S? That was our consideration. At U, this U here, it is the x-intercept of F from the graph of what? F of X. The x at U here, it is the x-intercept of what? X-intercept of F. That was the consideration. So meaning to say you had to solve that first to find the x value at what? The x value at what? At that point U. All right. So that's here x value. I'm just going to write xu. All right. From what? From f of x. That's the x-intercept where y is equal to what? Y is equal to 0 from the graph of f of x. So you simply take the graph of f of x, equate it to 0, calculate what? Calculate the x values, all right? There is a negative. Let's just get rid of that. Divide by negative, 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 negative. It was going to be x squared positive, negative, negative, positive, negative, negative like this. You can simply factorize. That was going to be x and x. Factors of what? -6, which will add up to a -1 in this case, the coefficient of what? X. So -6, there is -3 and 2. Multiply this, you get -6, add, you get a -1, -3 plus 2. So that will give us the x values. X is equal to -3 here. It's going to give us a +3. +2 is going to give us what? A -2. So those are the x-intercepts of F. So which one represents the x value at U? U is the one on the positive side. All right, from 0, it's one on the positive side. So when you say U is the one that is going to carry what? A positive, which is what? Which is 3. So the x value at U is 3. The -2, this one, guys, do not be tempted. The -2, it is the x value at T from the x-intercepts of what? Of F. T and what? T and U. Those are the x-intercepts. So there you calculated for U and for T, not for S. S lies on what? On G. So this here was going to limit us. We are done for this one, all right? So we have the x value at what? At U. From that condition, we have this one. What about the x value at what? At S. At S, S lies on what? On Gx. And we never calculated this before. So we're going to need the x-intercept of what? Of Gx, where Gx is equated to what? To 0. All right. Remember our Gx, guys, we calculated that equation of Gx. If you still remember, it was 4.4, and I told you guys you must remember that equation in case that you're going to need it. So from 4.4, the equation of Gx, remember we got 3, no, it was x plus 5. Yeah, x plus 5. So the x-intercept where y is equal to 0, x plus 5 is equal to 0. So -5 is equal to what? -5 is equal to x. So this is the x value at what? At S. Here we are talking about the x-intercept of what? Of G, which is the x value at what? At S. That is the x value at S here is what? Negative what? -5. The x-intercept of what? Of the line Gx that you're given. So therefore, the distance now from those calculations that we've done, guys, SU can be calculated. The X value at U, which is what? Which is positive 3, the bigger value, minus the minimum value, which is a negative, the X value at S, which is what? Negative 5. So that's our SU. 3 minus minus, that's a positive. So you're going to get a positive here. So 3 plus 5 is what? Is 8 units. So that's on a horizontal line. You work with what? X values. If it was a vertical line, you work with Y values. Y this and Y this. You subtract the upper minus the lower, upper minus the lower, or the bigger value minus the lower value. In terms of that, you are going to have what? The distance or the length, and that length must be what? A positive. The magnitude of the length is always a positive, right? Or you could have used the distance formula from S to U, use the distance formula x2 minus x1 squared plus y2 minus y1 squared, where you are going to have these as points. At U, it is 3, 0. At S minus 5, 0. You use the points into your distance formula. Still, you are going to obtain the same answer. You are not limited just to say subtract X values because it's a horizontal line. What if it was not? You're going to use what? The distance formula. So you can also use that. All right. You can also use the distance formula. So that was 4.7. 4.7. All right. Let us move on to 4.8. We need to determine the values of X for which, all right, f of x minus gx is less than what? Less than 0. Here they're just playing around with us. Here we have answered this type of a question, guys, a lot of times, and we do understand that when one of the sides is equivalent to 0, like what we have, we can take one of the given functions to the other side. All right, f of x minus gx, they said is what? Less than or equal to 0. Take minus gx, it becomes a positive there. So f of x is less than or equal to what? Gx. We are easily, like, we can easily solve for this one. It is the same thing as what we had on this type of a question here, which had f of x on 3.8. F of x is greater than or equal to gx. We are used to that one because we just compare, is it above the other graph or below? So in our case, f of x is less than what? Gx. We need, when it is below, less than, it is what? Below gx. Where is the graph of f? This graph of f found below the graph of gx. So you use the critical values, which are the points of intersection. Those are your critical values, points of what? Of intersection. When the two graphs intersect, you can tell that the other one from there, it is greater or it is lower in terms of the values of x. So our critical values were the points of intersection. At the point of intersection here, x is -1. At the point of intersection here, x is what? X is +1. Those are the critical values. So compare from those critical values to say for the values of x which are less than -1 on this side, what is happening on our graph? Is the graph of f below the graph of g? All right. So from -1, yes, if we check properly, the graph of f is below. This is the graph of g. The g is above, but f is what? Below. And this is the region that we want for values of x where f is what? Below gx. So we need this region for values of x which are what? Less than -1. But since there is an equal to, we are going to also put that on your solution. All right, let us move on. From the critical values, remember our critical values, -1 and 1. So in between -1 and 1, what is happening in between? In between this, we can see that our f is now above gx. It is above gx. We do not want that. We do not want, we want it when it is below, not above. Here it is what? Above. From -1 up to 1 at point F, this region is not to be taken. So we move on, because this one has failed. We move on to 1. From values of x, which is equal to 1, going to the what? The right side like that, going positive 1, 2, 3, and so on. What is happening? We can see the graph of F is now below the graph of what? The graph of G. It is now below. Like what we had in this interval here, it was below the graph of G was on top. That's exactly what is happening. F is now found below. G is on top of what? On top of F. What we need is exactly satisfied in that region here, that F is what? Below the graph of G. From values of X at the point of intersection, this one, X is 1, going this side. So these values, they are what? They are greater than 1. So we are also talking about the values of X which are greater than 1. There is an equal to on our question, so we must also put that on our solution. So those will be the solutions where f of x is less than or equal to gx, found below the graph of gx or equal to the graph of gx. Use the points of what? Intersection as your critical values. 4.9, calculate the maximum length. The moment you hear something like this, maximum distance, maximum length, maximum area, this and that, we are back to our quadratic function, where at the maximum value, if you are given a quadratic, all right, if it is y is equal to ax squared plus bx plus c, then the maximum value occurs where x is what? Minus b over 2a. This is the condition. But we need it from what? VW. VW. The difference between V and W first. What is the difference between what? V and W. This is what we have here. Here. That's 4.9. So we need the length first of what? VW. What is the length? Then we can determine the maximum length. All right. So let us start with the length first of what? VW. Is an expression, the length of VW here, not the exact numerical length where you substitute the value of x. No, there's no value of x there at V and W here. We do not have the corresponding values of x. So we need an expression, this one for VW, an expression for the length, an expression for the length. So how do you find that? You simply take the V, it lies, this is the one on top, minus W, the one which is below. So you need the Y value at what? At V. The Y value at V minus the Y value at what? At W. But we do not have that. So what represents any Y value at a point? It is the function given. The Y value at V is simply your f of x, as it is at that point of x which will be given. Since we do not know the value of x, so we take the whole function representing what? F of x. That's the Y value at what? At V. Your f of x. All right? Minus x squared plus x plus 6. Minus what? The Y value from the point W here is the what? The Y value which will lie on what? On our gx. So we simply take the gx as it is. Remember, our gx was given as what? X plus 5. As it is. Subtract that. So that's remove what? X plus 5. We have an expression for the length of VW. This is the expression. Minus x squared plus x plus 6. Expand brackets. Negative times x. Negative times 5. All right. So our VW was going to be minus x squared. X minus x, that's a 0. This one cancels. 6 minus 5, that's a positive 1. This is an expression for VW, an expression which is a quadratic. So for us to have a maximum value on a quadratic, as long as it is a quadratic, guys, for us to have the maximum value for a quadratic, we can use what? Minus b over 2a. So for maximum values, for maximum values. All right, x is equal to what? Minus b over 2a. So at the maximum value of this expression, x is supposed to be minus b. Do we have the value of b? All right, this is same as what? 0x squared. 0x, I mean, the coefficient of x is 0. So we've got a, which is -1. Our b is 0. So that's a, b, c. The coefficient of x, that's our b. So it was going to be -0. All right, the coefficient of x is what? That's a 0 there. Over 2 times a, 2 times -1. Guys, any number over 0, that's what? That's a 0. So we are saying for maximum values, x is, not to say that's our maximum value, no. At the maximum value, x must be what? 0 for this one. So therefore, the maximum length of what? The maximum length of what? VW is going to be what? When x is 0. When x is 0, put that in place of x plus 1. So that was going to be 0 plus 1, which is 1 unit. So that is the maximum length that we were going to actually have from the idea of maximum values, maximum and minimum values of a quadratic function, because that is forming a quadratic. So as long as you're forming a quadratic, you can use that condition at the maximum value. X is equal to what? Minus b over 2a. Substitute that to determine the maximum value. So you see, guys, these are applications. That is how they can give you these questions. Combined, everything combined. So you just need to work out as many questions as you can, and let there be light in our revisions as we are revising. So that was it, guys. 27 marks, a total of 100 marks in everything. So do more questions, all right? More question papers where you do not understand. Like I said, let us communicate through the comment section, through the community section as well. The community section, especially the community section. Send your questions there. Send your questions there as a picture. I do not know as for the PDF, but you can take a picture, then you post it self. Then I'm going to look into it whenever I am free. So that is the whole idea. Guys. Please let us do revise exams around the corner. So make sure that you give yourself much time into revisions. All right. It's not a guesswork. Mathematics is never a guesswork. You give it time. All right. The more practice, the more you understand math, as long it is about calculations, right? Your mathematics, your physical sciences, all those, they need what? A proper time. If you're doing calculations, subjects which has got calculations, they need proper time. Give yourself time to study and understand all the basics. But for now, that is it, guys. Till we meet again.